So let me just start with a brief overview of the ecosystem. So you see the four corners here on that picture. So each of the corners is what I call a pillar of the project. So you have traditional server virtualization up there, cloud computing. You're on this corner down there, that's the security guys. And on the right-hand side, we have a emerging market segment of embedded and automotive. Now, I briefly wanted to talk a little bit about recent security-related developments and also the status of some of the features you're building your products on. So obviously, I have to talk a little bit about Meltdown Inspector and what we did for that and what we're going to continue to do for future side channel type of attacks. So Meltdown, we addressed that via the XPTI, which is similar to the kernel approach. There have been a number of performance improvements in that area. There will be more coming. Spectre on x86, that's the SP2 variant, will basically pick the most appropriate mitigation based on what's available on your specific platform in terms of microcode and hardware support and so on. But there is a little bit of support how you can control that. So there's a spec control command line option, and you can basically manipulate the default behavior there. On ARM32 and ARM64, there's various mitigations for the affected ARM CPUs. This is a really old version of the presentation, but I'll just improvise. So some things might be wrong. I did send you one yesterday, but hey, never mind. So SP1, fundamentally, to exploit SP1, you need to have a suitable gadget in your code base. So Google Project Zero used the eBPF engine in a proof of concept exploit. We've been looking through the code base and haven't really found anything like that in our code base, but there's obviously no proof that something like that doesn't exist. Some of the large vendors in the community also have either written their own static analysis tools or have been working with companies which produce static analysis tools to try and find footprints of such gadgets. So far, also nothing has been found yet. In my real slide deck, I also mentioned SP4, which came out, when did that come out? This week, Monday. There the situation is basically exactly the same. It needs a gadget to control, to exploit. However, there are also microcode updates available, and for those, there is appropriate support which gets passed through to the guest operating systems, because some applications may need that to protect themselves against those exploits. I think they're switched off by default, so you would have to use some of the command line options to enable those. So let me just see. Yeah, so some of the slides I thought were there are actually there. So let me talk a little bit about some of the technologies which are now widely used. They're all security-related technologies. So disaggregation, we saw that's in use by OpenXT, SecureView, CubesOS, I think Derner works. Virtuosity has it on their roadmap. Starlab's Crucible as well, and then all of the automotive vendors which are building products for Xen as well today are using disaggregation as today. Then we have virtual machine introspection. That's a little bit more server-centric, but again, it's quite widely used today, and in fact fairly successful, particularly the Bitdefender implementation. Live patching, again, relatively new. I think really we just put that into Xen about 2 years ago. All the major Xen-based product vendors have that in their products today. And about 50% of all the companies on our pre-disclosure list use live patching today. So the good news is that these technologies are actually really well understood by our core maintainers and committers, and for that reason, the technologies are generally, well supported, within the product. So normally, if we have enough adoption in products, and if those vendors engage with the upstream project, then fundamentally, it's a given that the quality and support for that is good, and everybody benefits. However, there's a few wrinkles, right? So disaggregation, support status, we have them, they're, for example, supported and security supported in terms of driver domains and device model subdomains, but there's caveats. In this case, they primarily come from PCI pass-through, and we touch on that a little bit later. There's some missing upstream pieces, right? So, for example, it's not easy to build systems, disaggregated systems. In upstream, we have no way today of really doing this in a nice and neat way, and that also means we can't build it, so we can't test it, right? Now, I've been working with some of the vendors in the community. So for example, Invisible Things Labs, who does Cubes OS, they're committed to upstreaming some tests which help them with their own product. And they're also, committed, and that's what that link to that thread is. That's a relatively new thread, and I'm kind of looking for more of these kind of things from you guys as well. Same thing, like for Linux subdomains, we don't support that in a project today, because fundamentally we were originally betting on rump run, where we put a lot of effort in, and then the rump run project just died, so we kind of built on something which went away. But at the end of the day, the moral of that story is that if there was more engagement from users in that space, the support we would have in this area would be better. And hopefully, by being here, and if you have ideas, come to me afterwards, and we can figure ways out to where you can help us and we help you, because it's a two-way street. Other areas, measured boot. You guys, we've been practically all day talking about that. That's something, which a lot of you really care about. It's something which is not well understood by, the group of maintainers and committers we have in upstream. And so, what we have there is probably lacking and isn't really tracking, the developments you need. So this is an area where we could benefit from you helping us. Flask, quite similar. It's quite complicated. We don't have a lot of people in the community, except for in this room, who really understand XSM and SE Linux and so on. However, I know there's a desire amongst our committers to make this a first-class citizen within a project, and maybe even enable it to the average users. But there's some problems with this. So George Dunlap, who's one of our committers, took this on a year and a half ago as a pet project. And he then identified a number of issues, which, let me just kind of try and walk you through this. So basically, when you use disaggregation, you have your DOM0, and then you delegate functionality which would normally run in DOM0 in a DOM-U. And to do that, you need to basically up the level of privileges of that VM. And the way how you do that is you use Flask to relax, privileges of something which normally would be, a DOM-U and wouldn't have those privileges. And that's really risky from the viewpoint, of a novice user, which doesn't really know policies very well and doesn't understand, XSM and Flask and so on. And if you look at SE Linux, it's quite different, I think, because there primarily you always take away, you don't relax it, you just take away privileges. So it's a lot more foolproof. So how could we solve this? Well, we first thought about, well, maybe we can just throw a lot of testing at this, but it's complicated and not really easy to do. It also doesn't help because, it doesn't protect against, novice or stupid users just writing stupid policies. And maybe an interesting approach would be, if that's something you guys really care about, is to really change the model somewhat, by which we basically say, well, actually we could introduce a new group of privileged domains, and then instead of, relaxing privileges, we take them away. But that would probably be quite disruptive. So, in any way, so if this is something you guys care about, that might be worth having a discussion about. We have usually different ways of doing this. We can set up a community call or a discussion or something to sort of make progress in this area. And then, this was wrong. This was actually taken out of the slide. So here we go. There's been a few other changes recently as well. So we formalized the scope of our security process. So in the past, we were quite vague about what is security supported and what isn't. A bit like the British unwritten constitution, based on precedents. But at the end of the day, we wanted to become a CVE numbering authority because it's been just getting too hard to get CVE numbers lately. And one of the requirements is really to write down the scope of what you support in which circumstances. So we started formalizing this through support.md, which is basically, it's like a maintainers file. It kind of specifies all the components and how they're supported and caveats and so on and so forth. And then we generate, nice little documents from it now per release. And that threw up some, some areas which are maybe not as well security supported as some of our users expect. And it kind of comes back to the question, what needs to be in place for features to actually be declared as supported, i.e. good enough for everyone to be used, and for it to be security supported. And that means if a vulnerability is found, we go through the whole disclosure process and so on and so forth. So first of all, we need to have components which are functionally complete, sufficiently tested, interfaces stable, and so on and so forth. And then we would declare the feature supported. And in most cases, that also means that we would security support it as well. We have a few cases where we can rely on, if for example, so let me just think back. So the ARINC 653 scheduler, which DonorWorks maintains, we don't test these as part of upstream testing, but DonorWorks basically has a test suite and committed to testing it as part of the Xen release process. And so we're kind of happy with that, so we can fundamentally declare it as supported. So, I'm starting to run out of energy, I'm afraid. It's however, in some cases, just having it, this isn't sufficient for us to be security supported, and those cases are if we don't have the skills in the team to do that, then obviously, we can't respond to a security issue quickly. And there's a workaround for this as well. If we then had commitment, from an outside expert, which is part of the community, who will basically say, well, if somebody reports an issue and we come to you, and then you would have to basically drop everything and just help us fix this and get out a fix. And if we have that commitment, then we can also, security support these type of issues. So, other process changes. I already mentioned becoming a CNA. this is actually something where maybe if somebody knows somebody in DWF, please come to me afterwards. We had an in-principle agreement with MITRE middle of last year to become a CV numbering authority. But since then, the rules have changed, and MITRE doesn't award that anymore to open source projects. And this has been moved to DWF, and we don't really know who in that organization is responsible, and we're sort of stuck on that. So maybe somebody can help us there. Also, we're running a security process review. So the last time we checked our security process changed our security process significantly was 3 years ago. So I basically started a community consultation, got lots of input about, are we doing right? What could we do better? And so on and so forth. And the paper is posted there. So if you care about that, look at it and provide feedback. And then I had a few observations as well, right? So we do responsible disclosure. And we have quite a lot of companies, and organizations on our pre-disclosure lists because they qualify. What's interesting is that in that security space, only AIS, Bitdefender, and Invisible Things Labs are on that list, and I don't really understand why. As people in the security industry, I don't know. I would say, if you have a product which is Xen-based, you should probably be on that list and apply for membership. And come to me afterwards if you want to know how that works. So at this stage, I'm going to open up very briefly for one question. If you don't have any, I'm going to move on. All right, so let's move on. So we talked a little bit about recent developments, and so there's a number of really interesting and cool future projects going on. This is kind of in 2 batches. The first batch is primarily around x86 and general stuff, and then the second batch is primarily about automotive and safety certification. We talked about side channel attacks earlier, and there's, we just have to expect that there will be more and more of these coming over the next 2 years. So some of our core maintainers have been sitting together and trying to find ways to mitigate the impact there. And the basic idea is to remove sensitive data from the hypervisor to basically minimize the impact, of a side channel attack. Because if there's nothing there which is of interest, well, who cares, right? And the key problem today is that, because when Xen was designed, there were no side channel attacks. So there's a lot of state mapped into VMs today, into the hypervisor, which doesn't really need to be there, right? So the solution really is to basically take out stuff, which remove state from the hypervisor, and only kind of, map it in when it's really needed. And there's really a number of ideas there. Direct maps, for example, is something we should probably get rid of. Have per domain heaps and a lot of other things. And there will be quite a lot of discussion around this, I expect, at the Developer Summit in Nanjing next month. And then there will be probably discussions about this following it. The other big thing which is happening for a while now is the evolution of PVH brackets V2 support. So we're almost ready to release 4.11. So that will have PVH DOM-U, however, not with no pass-through support yet. PVH DOM-0 experimental. There's also the PV-Shim there, which was originally, we were starting this as a way to allow old PV guests to run, on PVH, such that we eventually could remove PV. But then it also turned out that it was an interesting possible meltdown mitigation. So we prioritized development on that. And then the other one is really clearly separating the PVH and HVM code paths. And we've made quite a bit of progress there. So what's next is to basically enable PCI pass-through for DOM use. That will require going over a lot of the code which is still there and inspecting it and so on and so forth, because obviously DOM use have less privileges. Well, we have to care a lot more about privilege escalation in that space. We have to look at performance tuning. So hypercall performance of PVH guests is lower than on PV guests, so that could impact overall system performance. And then complete the PV HVM code path separation, which eventually will allow us to build an HVM only or a PV only hypervisor, which is interesting from a TCP and attack surface perspective, because if you take half of the code out for your specific use case, half of your attack surface has gone. And incidentally, if you use PVH, you also don't use QEMU, then that's gone as well. 5 minutes. Oh gosh. All right, so you can look at this afterwards. This is some examples about code size and what might be possible. And then I'll just do a little bit about embedded and safety certification. So there's a number of really interesting projects going on, driven by various companies in the ecosystem. So they're most progressed from the top. So I won't walk through that. Have a look at the slides afterwards. And if you have questions, just try and find me. Also, for safety certification, code size is really important. So on a full ARM64 build today, we have about 60,000 lines of source code that excludes, DOM0 and everything in it. We started to do board-specific configs, so we can get down to about less than 50,000 lines of code, and that kind of makes it, that sort of makes it achievable from a cost perspective to really look at safety certification from an automotive perspective. We also have a plan, a straw plan together on how we might do this. So the most relevant parts there are we need to find a way to get DOM0 out of the system. So that's a project which is currently being done by EPAM that just started. They expect to have a prototype based on FreeRTOS in Q3 sometimes. And then when we have that, so we already started on getting the Xenon ARM size down. We have a baseline of what might be achievable in terms of lines of code. In parallel, I started working with PRQA, which is a code coverage company who wants to work with us and make some of their tools available for free to key community members. And then we basically have to sort of start trying to address some of the issues the static code analysis tools throw up. MISRA is a little bit controversial, so there will probably be quite a few bike shed issues where we will fight over. So I just want to do a few of those, see how this goes, and then take the data to see how we can move forward. Based on all that output, we can get a sense of the scale of the problem and how to attack it from a business perspective. I've got a few ideas around this. We've been talking to quite a few companies in this space now. Since we've been communicating this draft plan, I've also had the one or other car manufacturer approaching us and talking to me and some of the other companies who are active in the space. So it looks as if there's enough momentum to actually do something, but it's still very early days. if you're interested in this, come to me afterwards and I can make the right connections and we can take it from there. I'm going to give this a miss for now. I kind of covered this already. Stefano and Praveen from Washington University are also looking at a DOM0-less option. It's very early days. It's kind of centered around the idea there's a prototype where you can boot VMs from device tree on ARM. Obviously, that would work on x86, right? But this is something which could potentially be morphed into a system without a DOM0. And given that I don't have time, I'm going to skip this. Pardon?
This one's pretty important, so why don't we...
Okay. All right.
Competing project OpenXT. Trying to be very fair.
Actually, it's not a competing project to OpenXT as far as I understand. But hey, so currently there's a proposal for a new project out there. It was launched by Stefano. There's 2 or 3 companies behind it which are still in stealth mode, and they've been developing this for the last 6 months. And it's fundamentally tries to address the issue of being able to build this aggregated system. So in that sense, yes, it's competing to OpenXT because you can do that too, right? They're also having an intention to have a secure, measured boot and stuff like that in it, and it's going to have container support, and that means kind of Docker support all over the place and built strongly into it. So from the build side, I'm just going to focus on a picture at the bottom. So what do you see here is each of those boxes is fundamentally a build process. Each of the purple boxes is an output. So you can basically just rub existing build processes like a Yocto build, or maybe even an entire OpenXT build. It gets stuffed into a Docker container. It then produces output as a Docker container. So if you want to play in that system, you kind of have to make slight modifications to that, to what you do, but it's presumably just a few commands after your regular build. Then there's like an image format generator, and it then incidentally also runs in a Docker container. And then it produces an SD card image. And the idea is really that it's quite flexible and extensible, and you can kind of really pull different parts of the system together from different places. Here, for example, you would use Alpine, the Alpine build system to use your user space, and you might use a Yocto-based build system like OpenXT to build the kernel, and then it just pulls it all together at the end. So that's the one part. The other part is basically to build disaggregated systems and to have measured boot support. I think none of that is really there yet. I think the build system part is the one which is most evolved at this stage. And the container part is kind of already there. And what that does, that is built on some work which Stefano had done, presented last year at a developer summit, where you can basically you run a Docker container within a Xen VM, and it is tied into Kubernetes currently via stage 1 Xen, which is fundamentally interfacing with Rocket, which unfortunately, since Red Hat has bought CoreOS and Rocket, that project has died. So we have to take some of that work and rewrite it against a different set of APIs. And then you can basically, spawn. You can spawn, Docker containers which running Xen VMs natively and manage them through Kubernetes. And that's the basic idea there. And yeah, I'm going to skip. Then I was going to talk a little bit about competition. I'm going to have you guys look at that afterwards. Unless you have a different opinion, Rich. Well, you told me 5 minutes, right? Originally I had 45, and you know, you squeezed my slot a little bit.
I know, sorry, because the guy needs to get us out of the building.
Okay. All right. Okay, so I'm going to skip that, and I'm just going to ask you for how you can help the project and help yourself, right? So, obviously, I'm always going to ask for development contributions. I think one area which would really help would, if there's a lot of development and stuff happening right now, if you could review, you know, our RFCs and patches in those areas to make sure it actually doesn't hurt you in the end, that would help us and you. And we actually introduced a mechanism now in a maintainers file where this can easily manage. So we have an R tag, which we could, for example, map, you know, security-related components to the OpenXT list, and then you get notified when something relevant gets posted. That might be an idea. Test contributions. That's an area where, you know, which is also useful for you guys. If you test some of the stuff you depend on, then you get less breakage when you upgrade. And, you know, things help guide us on some of those larger projects and help us with documentation where we don't maybe understand things so well. You can also help with funding the various others, you know, like funding. You can join the advisory board. That's quite expensive, but, you know, sponsoring events or even just sending, you know, some of your engineers to Xen-specific events would help. Other ways how you could help is donating hardware. What you see there on the right is actually Renesas paid EPAM to build a server chassis for their Renesas art, you know, boards, such that we can just easily plug them into the data center without having to worry about cables. So they basically look like a server, but are actually embedded boards, and they just sent us a few of those. There's also services and so on, which you could donate and sponsor. For example, Rackspace pays for our entire infrastructure, you know, web real estate. And another area which is relatively easy, where, you know, I don't really know much of what you guys are doing in general from a product perspective, or how you use Xen. This is something, you know, if you tell that more publicly, we can help you tell that story, and it would help you and us as well through visibility. And that's fundamentally it. And then I guess questions will be at the pub afterwards, and hopefully tomorrow the last speaker won't be in the same situation as me and get the slot cut by 15 minutes. Sorry, I just had to be cheeky.
Okay.
No questions. All right, find me in the pub.